Hi, everybody. Welcome back. We're continuing our discussion of lighting calculations and the lumen method. All right. And in this video, we're going to focus on the coefficient of utilization. All right. This is one of those factors that is going to make our lighting calculations more realistic. Not all the lumens produced by a lamp actually make it to the work surface, so the coefficient of utilization is a multiplier, all right, and it's used in our calculations to account for the efficiency of a specific setup in a particular room, all right, particular lamp, particular luminaire, particular room and layout. And so it's a ratio of the initial lamp lumens, those are the ones that you can get from the spec sheet, from the cut sheet, to the actual lumens that arrive on a work surface. Depends on the specifics of the space and the lamp and the luminaire. A design with a high coefficient of utilization will deliver more light to the work surface, all right, in this case a display surface, all right, than a design with a low coefficient of utilization. How do you find the coefficient of utilization so that you can use it in your calculations? Well, it is available from your luminaire manufacturer. In order to find this number, you need to know the surface reflectances in your room and also the room cavity ratio. I'll talk about just both of those in just a minute. Or you can also use some generic values if you don't have any of that information available to you. All right, so to get the coefficient of utilization, you need to know surface reflectances and room cavity ratio. Let's talk about surface reflectances first. Your room surfaces are typically your walls, ceilings, and floors. Light is going to bounce around your room and off of all these surfaces. Each type of surface will have a reflectance value to bounce the light around. So if less reflectance bounces less light, more reflectance bounces more light. All right. Now, you can find the specific reflectance values for your surfaces, and this is a really good idea if you've got anything special. All right. But you can also use some typical values, all right? And if you're doing standard commercial work, your typical values are going to be 80% for the ceiling, 50% for the wall, and 20% for the floor, all right? And if you look closely, in fact, that is what is used in your textbook example, all right? Floor reflectance, 20%, ceiling reflectance, 80%, wall reflectance, 50%. The next piece of information we need to calculate your coefficient of utilization is the room cavity ratio, or RCR. Right? This is a formula that takes into account the proportions of the space. So it's all about the room, okay? And also the distance from the luminaires to the work surface. All right? It's going to use the volume of space in between the luminaire and the work plane. Here's the formula to calculate your room cavity ratio. And right down here, you see is how it is printed in your textbook. I actually think that's confusing. So take a look. This is the exact same thing written slightly differently. All right. And this is how you're going to calculate your room cavity ratio. You need to know the length and width of the room. All right. This is like in plan view. And you need to know the mounting height of your luminaire over the work surface. What is that mounting height? It is the difference between the work surface and the bottom of your luminaire. This is a vertical distance. All right. You typically measure your work plane height about 30 inches above the floor. And make sure it's measured from that working plane and not from the floor. So let's try a calculation example. Go ahead and pull out your calculator and your pencil and figure out what is the room cavity ratio for this room. The width is 12 feet and the length is 15 feet. The ceiling height is 10 feet and our work plane height is 30 inches. pause the video and see if you can come up with an answer. All right, welcome back and let's see how you did. So the first thing that you need to do is realize that with a ceiling height of 10 feet and a work plane height of 30 inches, your mounting height is actually going to be 10 feet minus 2.5 feet is 7.5 feet. Therefore, we can plug all of these values into our room cavity ratio. Room cavity ratio is going to be 5.6. You generally have to round these to the closest whole number. We're going to round it to 6 and use that to find the coefficient of utilization. All right. In the example on your textbook, if we select that particular luminaire, all right, coefficient of utilization, we found the floor reflectance, ceiling reflectance, wall reflectance. Look down this column. Now we need to know the room cavity ratio. Go ahead and find 6, and we'll end up with a coefficient of utilization of 34. So to recap, in order to find the coefficient of utilization, you need some information from the luminaire manufacturer and the surface reflectances and the room cavity ratio. All right. Or you can use some generic values. If your luminaire is a direct distribution luminaire or a downlight, 85%. For an indirect luminaire, maybe 50%. For a spot or an accent luminaire, 95%, and a wash luminaire or maybe an ambient luminaire, you'll get about 75% of that light. Okay, only use these if you don't have the other information. Let's compare our calculations of the lumen method, all right, without any of these safety factors of the luminaire light loss factor or the coefficient of utilization, and then with those factors. So starting here, and I'm using that example 8.1 on page 179 of your textbook. If you calculate using the lumen method simply as lumens divided by area, you would expect to have about 75 foot candles in this room. However, if you take the calculated safety factors, all right, the ones that we just did and are used in that textbook, all right, of 85% and 46%, you see that you're actually only going to get about 30 foot candles in the room. This is a huge difference, 75 to 30. All right, but you say, okay, Sarah, I'm just going to use the generic. This is too hard to calculate. Take a look. If we use the lumen method with the generic safety factors, well, the light loss factor is 85%. We're spot on. All right. But taking a look at that luminaire and realizing that it's a downlight, we used the 85% generic coefficient of utilization. That was a little too high for this particular luminaire, and we ended up with a illumination level of the room of 54 foot candles. This overstates how much illumination we're actually going to get. All right, it's not as good of a calculation. All right, everybody, in this video, we continued our discussion of the lumen method of lighting calculations and focusing in on the coefficient of utilization and how much light actually arrives at our work surface given the geometry of the luminaire and the room and everything that the light bounces off of. Thanks.